Top Bed Talk.
Monty Mython here. As we prepare to move into the next phase of the COVID crisis, we're going to be widening our focus here on Top Bed Talk. We will continue to deliver COVID-specific programs, but we all have a huge additional responsibility as we try to reboot normal services. So although this piece is not directly related to COVID-19, we believe it's information that is crucial to the bigger task of rebuilding the healthcare system as we learn to adapt and live with this new virus. Thank you to our sponsors and to you, our listeners, for helping us to share this important information.
Nick Majerison here. This piece was recorded at last year's 21st Current Controversies in Anaesthesia and Peri-Operative Medicine and SIAA Autumn Congress at the Dingle Skellig Hotel in Ireland. Have a listen.
I'm Mike Swart from Torbay in South Devon in England, who's chairing this session. I'd like to introduce our first speaker of this session. It's Dr. George Thornton, who is a Professor of Anaesthesia and Intensive Care down the road in Cork.
Thank you very much, Mike. Down the road, I've just driven up this morning, and it's not just down the road, it's an adventure getting here at the best of times. I'm privileged to be here. It's a real pleasure to be here. I love Dingle, and I've heard so much all good about this meeting. Jan, I'm very grateful for being invited. I was asked to talk about some research articles related to medical education. They were certainly interesting to me. These are the three articles I'll talk about. One of them is not a research article at all. It's an opinion piece by Roger Kneebone, who will be familiar to many of you, I think. The second one is a slightly technical paper about the use of artificial intelligence for evaluating, measuring or classifying human performance in surgery. And the third one, I've taken the liberty of including one of our own articles, that by Karthik Srinivasan, regarding a particular type of training we call proficiency-based progression on clinically meaningful outcome, that of analgesia after epidural in labour. So those are the three articles I'll talk about. When I say our article for the last one, it's very much Karthik Srinivasan's article, and there's a supporting cast of quite a few who helped him with it. First, this is in the Lancet earlier this year. It's by Roger Kneebone. Roger is a surgeon. He's a general practitioner. He's an internationally renowned medical educator. And he wrote a one-page article entitled Looking and Seeing. And the gist of it was that medical practice is about observation, and that we're progressively getting worse and worse at observing, both as clinicians and in terms of medical students and trainees, that technology has somehow subvented our natural tendency to observe carefully when there's something of interest presented to us. He bases the article around this lady, who is Erica McAllister, who's a collaborator of his. She is an entomologist. She studies insects. She's got a staggeringly multi-syllabic title. She's the chief curator for Diptenology and Siphonoptera in the National History Museum in London. Ask questions at the end if anyone wants to repeat that back to me. And entomologists apparently are experts at observing. They observe, and much of their work is based on observing form and structure, and then function, relating the two together. And they're expert observers. The line or two within this that's caught my attention were almost the last lines. He mentions that while he and Erica are chatting, a fly flies past. And Erica, at a glance, has identified the fly, not by name, the type of fly that is there, and the behaviour of the fly, and has much detail to say about the fly. In the meantime, Roger didn't even see the fly. And that's the significant bit. It wasn't that Erica has lots more information about flies and what they look like and what they do than Roger. He didn't see it. In his world, in his perceptual experience, it was not there. So that's interesting. It fits perfectly with a sort of theoretical framework, an idea that is now prevalent in medical education. It was first put forward by a Russian educational psychologist called Vygotsky, It's called the zone of proximate learning or development. Some of you will be familiar with it. It's now a term that's used quite frequently. The idea is really simple. It's that we only learn what we are ready to learn. So that we walk around with sort of functional models, paradigms of how things should work in our world. And if we're presented with a new element that belongs within that model, that fits sort of safely, securely, comfortably within that model, it registers, but it doesn't set our pulse racing. We fit it in, we tick a box. We don't deliver an awful lot of attention to it. And if we're confronted by something that's extremely remote from our working model, unless we're a very exceptional person, we ignore it, we prune it. In other words, it's not there, it didn't happen. But where we are active, where we do engage, is at the boundaries of our working model, where something challenges an edge to the working model, and we're forced then to see, is there something wrong with the model that I can't fit this in, or can I fit this in? And now there's an operation at work. Vygotsky's theory, the zone of proximate determinism or development. It brought to mind an event of about 10 years ago when my friend and colleague Tony Ryan, who's professor of neonatology in UCC, came into the office one morning and said, we have to get the medical students to be better at observing. And Tony is very persuasive. And I was thinking, oh my God, this is not good. I was picturing the microbiology group who are going to have to lose a lecture slot or a tutorial slot so that we can put some bloody observing into the curriculum. And he said, look, I'll show you how it works. And he brought me along to one of his sessions. So he has a group of 12 fourth-year medical students who come to the neonatal intensive care unit. The cutting edge of modern medicine, at least to my eyes, 40 cots, tiny little preterm babies, many of them connected to machines. And he brings them to the door of the neonatal intensive care unit and turns right into the tutorial room where there is a painting. And he sits them down and he asks one of them, what's going on? What's going on in the painting? And he gets an answer. And then he asks another one, how do you know? How do you know that's going on? How did he know that was going on? And then finally, someone is asked, what else do you see? And having spent maybe 20 minutes doing that, they go in to the fairly hushed environs of the intensive care unit, and he does exactly the same. At a particular cot side, once he has exchanged some of the background. What's going on? How do you know? What else is going on? That's exactly the process that Erica McAllister was doing when the fly went past. Okay, this is slightly different. Group from McGill, very well established as both an artificial intelligence group, data analytics before that, and a strong neurosurgical input. What they presented in JAMA, Network Open, earlier this year, was an article describing a prospective observational study, point in time, where they attempted to determine whether a machine learning approach, that's a form of artificial intelligence, could be used to correctly identify different categories or qualities of performance of a particular neurosurgical skill. So this group, many years before, had developed the state-of-the-art virtual reality simulator for training neurosurgeons. And they created a task within this, which was excision of a primary tumour. It meant achieving hemostasis, doing some dissection, and then excising the tumour. They then took data from 50 people. Some of them were neurosurgeons, consultant neurosurgeons for 10, 15, 20 years experience, some senior trainees, some junior trainees, and some medical students. They all did the same task. They each did it 5 times. They averaged the performance metrics over the 5 efforts. And then they attempted to use machine learning to correctly classify the individuals amongst those 4 strata or classes. So that's how they got on. So of the true 14 neurosurgeons, the best of the algorithms identified 12 correctly as neurosurgeons, 1 as a senior trainee, 1 as a junior trainee. Interestingly, of the 12 medical students, the algorithm identified 1 of those medical students as a neurosurgeon. So, overall, a 90% accuracy rate, which, depending on how you look at it and how high the stakes are, is either okay or not very good. Let's take a closer look. I present this because I believe, and I'm willing to stake a wager on this, that within 5 years, this approach, if not these exact algorithms, will be part of our day-to-day lives. Whether it's continuously for pretty much everything we do in 5 years, I think that's unlikely, but intermittently we will be exposed to some form of machine learning which estimates how well or badly we're doing different things within our professional life. So how exactly did that work? So you've got the idea. The first thing was the instruments that are being used are sensorized, so it's possible to extract certain measures, metrics, as to what they're doing within an enclosed three-dimensional space. Think of it as X, Y, Z coordinates. So now you've got a lot of potential metrics there. You've at least 1 instrument, usually 2 instruments over a period of time. The position of the instrument could be a metric. At any particular point or during an interval within the performance, that would be a metric that you could use to classify. First derivative of that would be the velocity of the instrument tip over a particular time. First derivative of that would be acceleration. The first derivative of that, an entity referred to in their study as jerk, a rate of change of acceleration. So they examined some of these through trial and error and find that some of them discriminate quite well between putative different groups and some of them don't. They ditch the ones that don't. They've selected some metrics, and now it's necessary to actually put quantifiable limits. Does this value of this metric identify one group rather than another? Is there a range that's particularly characteristic of one group or another? Now we've got a defined set of parameters, and then they simply applied fairly standard machine learning approaches, an algorithm, to each of those, testing them to see whether they classified the individuals correctly or not. Typically, for machine learning, a training data set is presented such that the algorithm is built around its accuracy or its ability to create propensity or predictive scores that are fairly accurate. It produces an output that is either a classification, it's got it right, this is a neurosurgeon, or regression, some sort of measure, the likelihood that this entity, this being, will produce a high value or a low value. Both of those are standard outputs of a machine learning approach. A critical part of it is whether the input data is labeled or not. So you can imagine it's much, much easier to train a machine to use an algorithm if it's coming with a label. If you're telling a small child, or would like to explain to a small child what a pig is, you might show a picture of a pig and say, pig. And then show a picture of a horse and say, not pig. And then do that several more times. And eventually, the child will realize that the picture of the pig, for some reason they'll have captured, is actually a pig. So that's supervised learning. And in terms of machine learning, that's supervised data input. That was the form that was used in this study. Of all the different approaches they used, the one that was most successful, I show you the results from it, is referred to as KNearest Neighbor. And it's a very simple, intuitive idea. It's that if I can position a particular entity, think of one of the individuals who did the performance, based on XYZ coordinates, but of parameters that are relevant to the quality of their performance, then their position is likely to represent the quality of their performance. And if there are different classes presented, classes of those individuals presented, they're likely to be close together. So their proximity becomes a measure of their likelihood of belonging to the same class. Final idea. It's called KNearest Neighbor because it's possible to turn up and down the gain switch for that likelihood that one belongs to a particular class or not. Imagine for a moment that we're asking the question, green circle, is that really a red triangle? Does it belong with the red triangles, or does it belong with the blue squares? We adjust the gain switch. Initially, we start with the closed circle. Remember, proximity is what we're going to use to determine whether or not it belongs to a particular class. So within that circle, that's the only data I'm going to look at. It's proximate, close to 2 red triangles and only 1 blue square. So it's clearly a red triangle. Change the gain switch a little to the dotted circle. Now we've got a different outcome. It looks like within the dotted circle, we have proximity to 3 blue squares and only 2 red triangles. So clearly it belongs to and is a blue square. Now the relevance of that to the paper is that as we shrink the number of input points, the input data, we're more unstable. It only takes one piece of misleading data to throw us off. And the magnitude of the input data, even though it's supervised machine learning, which normally is effective with relatively small input data sets, it's still unstable. It can be misleading. So now to take a step back from the paper, I said this is going to be part of our lives in 5 years' time. I'm not sure whether you agree with me on that or not, but it will present challenges. If we're to do something like this that works better in terms of predicting or measuring performance, we're confronted with really difficult questions. In terms of performance, just think technical procedures for the moment. Is there such a thing as expert performance of any of the techniques that we do daily? In other words, if you deconstructed how one person puts in a central line and another person puts in a central line, will there be a similarity between those who tend to do it successfully and well without adverse effects or not? Is there such a thing? And it's quite possible that experts are experts not because they're doing things in a similar way, but because they have found a way to produce a good outcome. And they may do it in an enormously different set of ways. We may take shortcuts if we become expert at a particular technique. We may have insight into our own failings and compensate in one part for another part of the procedure. Experts, we know, at points where one would want a beginner, a novice, to slow down, very often speed up. It probably reflects the fact that they're actually concentrating very, very hard at the time they should be concentrating very, very hard. The other is, if you were to do something similar to this again, that any time expert performance has ever been evaluated quantitatively, the experienced anaesthetist, the experienced surgeon, there are always 5 to 8% who lie 2 standard deviations on either side. There are always about 5% who lie 2 standard deviations below what one would consider a proficiency threshold. Okay, third paper. This was conducted at Cork University Maternity Hospital. Over a period of 3 years, Dr. Srinivasan and his co-investigators set out to develop a type of training for insertion of epidurals in labour. It's referred to as proficiency-based progression training. I'll explain it a little in a moment. And he then set out for the first time that we know of to examine whether or not that type of training had an effect on a clinically meaningful patient outcome. So this part, the trial part of the study, entailed about 1 year of trainees coming through training in Cork University Maternity Hospital, randomly allocated to 2 groups, this proficiency-based progression training or standard training. Those who underwent proficiency-based progression training, for now, consider that a black box. It didn't take enormously more time than the standard training, and it didn't cost the world. The primary objective was no adverse effects and satisfactory analgesia within 60 minutes of inserting the epidural. So that constituted success. Anything except that was failure. And there were a number of secondary outcomes as well, including the patient's overall satisfaction with their experience in hospital, satisfaction with the performance of the procedure. The bottom line outcome was that the failure rate in those who had undergone proficiency-based progression training was half that which it was in the standard training, or standard training which has been used for many years in SIAA. I'll just say a word about what that proficiency-based progression training is. It was pioneered by Professor Tony Gallagher, originally in Yale for surgeons undergoing laparoscopic surgery. This first paper, by the way, is the most cited publication in the surgical education or training literature ever. So the approach is quite a simple one in theory. So the idea is that you identify a particular skill, that's then characterized by using the filter of expert input. A small group of experts are asked, can you do this? Should you do this? Should you avoid doing this? And what's generated is a set of metrics. Observable behaviors are steps, errors, things that should not happen, critical errors, things that really should not happen. These are stress tested so that the wording of the definitions is very clear. And then that is prospectively validated. Do these actually distinguish between expert, intermediate, and novice? And if they don't, it's back to the drawing board. Once we get to the point that the metrics are defined, 3 things happen. 1, a proficiency standard. Now, this is this is a number. A proficiency standard is established. So this is okay, this is not okay. 7, 19, 54. An assessment tool which is valid and reliable is generated, and then a training program based on those metrics. So targeting the metrics, not targeting the procedure, targeting the metrics, but in such a way that one only progresses through it when one has achieved a satisfactory proficiency level at the previous step. And then that's incorporated into clinical practice. Currently, if you're a neonatology trainee in CUH, out of hours, if you insert an endotracheal tube or a PICC line, you must wear a camera, you must switch it on, download the video afterwards, use that to evaluate yourself using a predefined set of metrics, and you quality control with your supervisor at the end of your term. That's a whistle-stop tour through some of the articles on medical education that I found interesting. Thank you.
Top Med Talk.
Thanks for downloading Top Med Talk. The time has arrived for you to get yourself your ticket to EBPOM Dingle. That's right, one of the most famous conferences in the peri-operative sphere is going ahead. We've taken EBPOM Dingle virtual. The 22nd Current Controversies in Anaesthesia and Peri-Operative Medicine and SIAA Autumn Congress will go ahead virtually. Live from Dingle, Ireland, you can attend this incredible conference. Spoken of frequently here on Top Med Talk in hallowed terms, it is of course a place that is known to produce results. EBPOM Dingle. Check out ebpom.org and get yourself online for the Conference of the Year, EBPOM Dingle 2020.